So, hello all. Welcome to me and the friends of mine's presentation. Opi, sorry he couldn't make it on this presentation. Uh, we this is a presentation this is a research that we started a while ago on how we can bypass the one of the security. Well, technically AWS doesn't call it a security feature, but one of the quasi-security features of AWS, and we started with the compromise or the quarantine policy, as I usually call it. First things first. This is us. So my name is Bleon Proko. My handle is Glasses Boy. We also have Opi. These are the heroes of bypassing the quarantine. And just to emphasize on this talk has nothing to do with COVID or anything related to it. It's just the way they call the policy. Now, throughout the presentation, we will be talking about what the policy is. We will be talking about what privileges does it restrict and does not restrict, how we can bypass it, how we can bypass it with style, and also what we do next. Just to emphasize one thing about the policy, something that I've seen people get confused by. This policy does not allow anything. This policy just denies stuff. The thing is, what does it not deny is what we are mostly interested in. Let's just, anybody here works at CrowdStrike, or anybody here works with CrowdStrike? This actually hits, I guess this hits home. So let's presume that, that you have just a code push. And after you get you push the code, especially a public one, you get one of these emails, which say your identity has been leaked or compromised. They either say we attach the policy. I'm going to name it quarantine policy because it, as I said, it's a mouthful, or it says, yeah, your account is locked. Usually, that's the next part for a couple of days. But after that, you just go read the documentation and just look that, okay, this policy is a good thing. It's something that AWS attaches so you can at least protect yourself. What can they prevent those credentials from being impactful. You look at the policy, you see the document, you see that there are different services that, with a deny on basically a lot of calls. There are, if I'm not wrong, 8 services that are being impacted, which means, yeah, you have a lot of restrictions. And you're like, okay, how? Now, for the people that don't work with cloud, this is just an intro. Everything in cloud is API. So you have every privilege, at least in AWS, almost all, if not all, of the privileges are always attached to an API call. Meaning, if you have attach user policy, you will have a command, an API call called attach user policy, which will do a certain task. That makes it a lot easier to define privileges because you know what you want to do and how you define everything. Privileges are defined in policies. Policies are just basic JSONs with the actions and with the effect being allow or deny. In AWS, the deny always goes before allow. Meaning if you have 9 policies which allow, let's say, 200 events, and then you have one deny policy which prevents those 200 events, the deny will always go before the allow. Which means by now you might have understood that the first one there is what the privileges the identity has. The second one is the quarantine policy, meaning the quarantine policy with 3 events that denies will deny 3 out of 4 privileges that the identity has. And the ones that are not prevented are the ones that we will deal with. So what are the stuff this policy does not limit? Now, how much of a security feature can the quarantine policy be considered as? Even AWS doesn't consider it a security feature. They consider it mostly fraud prevention. Not actually a security feature, but I've seen a lot of people consider it a security feature, at least a security on top of their leaked credentials, especially when they want to not change the credentials immediately, the leaked credentials or the compromised credentials immediately. The reason why I say compromised is because whenever AWS finds out that an identity is doing something that an attacker is known to do, create a specific user or something, they will again log the user. Now, let's go to the AWS, the quarantine policy again. If we look at the policy, we see that we have 5 events which are read-only events, okay? We have, aside from that, everything else is write events, which means we are not allowed from doing these things, but we are not prevented from doing all of this. Meaning, when it comes to enumeration, and enumeration is usually done well, I don't know if any enumeration that is done with write calls, but is done using read API calls, meaning you can do IAM enumeration, basically any other enumeration. You can download secrets, you can get KMS privileges, you can also get other, you can get buckets, you can get bucket contents, you can download the objects, meaning when it comes to enumeration, aside from those 5, nothing else is limited, so that's where you will start to look at first. Then, which means we have one way that I don't see many people use, even though it's a really good way of, especially for people who have the right privileges, and usually on penetration testing, I've seen on AWS penetration testing, I've seen people get the read-only access. So it means they will get this access to enumerate the resources. Simulating policies. AWS doesn't allow you to necessarily see what privileges you have. What they do allow you, so you will need to have the right privileges to know what privileges you have. It's not that like you know by default what your policies are. If you have simulate policy, what you can do is you can get a list of all the policies that you have. You can get the permission boundary, which is basically a restriction that you might have, and you can have stuff like the SCPs, which are again a restriction for the whole organization. And then you can say, am I allowed to do something? And it will say you are or you are not allowed to do that. This goes for the user policies, or you can even check a resource policy. Am I allowed to touch this resource? Which is a nice way to enumerate something that do not restrict. Another thing, as I said, you are allowed to enumerate stuff. One of the enumeration is the Lambda functions, meaning you can download the functions or you can just get the environment variables, which more often than not will contain other credentials. Lastly, you are not prevented from downloading secrets manager or secret manager secrets, meaning usually secrets manager will have other credentials, especially more impactful one. And one thing I'm seeing people do is that they will have an application with a set of credentials which will be public, and those credentials will have secrets manager access to access another set of credentials to do another task. Meaning, if you have that, you are not restricted, which makes availability possible, but on the other hand, makes security not possible, especially if you don't restrict the access. Now, let's say that we managed to do enumeration. We want to know if we can escalate our privileges. In 2019, correct me if I'm wrong, RhinoSec released a list of privilege escalations, which they continue to update until right now there are 28 confirmed privilege escalations. We looked at them and we matched it with the quarantine policy, and 20 of them are not allowed. Those 20 are stuff like add policies to users, add policies to resources, to roles, add roles to other resources. But there were 8 of them, 4 of which were partially allowed, and the reason why they were partially is because they were mostly based on the fact that you could give the resource another set of privileges. and 4 of them were flat out allowed. The partially allowed technically give you other privileges. It's just that it doesn't give you full administrative privileges. It will give you some other access. Like, for example, you can access glue environments. So glue environments will have an instance of their own. And as we know, instances have roles. In AWS, most of the resources have roles. They will have a role, and the role will have privileges. By default, the glue environment will have 3 policies attached, and with the option that the user is given for a 4th policy, which is the S3 full access. And the only thing you need to do is just update the endpoint to put your own set of SH credentials, and then just get the endpoint, update the endpoint, and then SH into that, and then you will get access to the instance roles. With that, you get access to do a lot of stuff, like you can list all the buckets, you can do enumeration if you couldn't do before, you can do enumeration in IAM, EC2, S3, and also something that the policy by itself does prevent, which is running EC2 instances. Running EC2 instances is bad because that allows you to create an instance, which is something that we have seen attackers use for crypto mining a lot of times. Next is assuming a role, and this is something that I was actually confused by, because assuming a role will give you access to that role's credentials. Of course, provided that you have access to the role, you are not allowed to change the role's assume policy, meaning you are not allowed to give yourself access to the role, but if you do have access to a certain role, you will get access to the privileges, and I've seen a lot of roles that have very bad assume privileges. And this, yeah, by the way, this goes for all the assume role. So you have assume role, the normal one, you have the ASAML assuming, and the web identity, meaning you have all the assume, especially if you have an identity, if you compromise an identity that works as sort of an IDP-ish, it will give you a lot of access. Next, you have the modification of Lambda layers. So Lambda is basically a code in cloud. It's a code that is executed when a trigger is, well, basically triggered. As code, it requires libraries, as any code does. The libraries in AWS are called layers. You can modify those layers, and those layers are also cross-account, meaning you can have the layer on your own attacker account and then attach the other function on the target's account to that layer, and it will use it, meaning you are not even leaving a trail for the defenders, and you can execute code. And in this case, as you can see, I am actually doing a remote code execution to get the environment variables on which you get the temporary credentials of the Lambda role. That is also a good persistence method, because you can just modify a certain layer a little bit, and it will allow you to basically just have credentials each time the function is invoked. So when they invoke it, you will have a new set of credentials that you can use. So right now you have credentials all the time. Next, so CodeStar was deprecated on August of this year. So this only works for projects that were created pre-August 2024. You can, so on projects you have team members. You can just add yourself as a team member, and you will get access to the CodeStar and its privileges. Again, you will be able to get those privileges to escalate them. Lastly, same thing, you have SageMaker. SageMaker has an endpoint, a web endpoint that you can access. You can just request a pre-signed URL. You will get access to it. Again, you can get the roles of the SageMaker endpoint. Another thing, one thing that I believe in is that you can impact an infrastructure without necessarily getting access to the administrative access. And usually, if you are a threat actor, you will do this more than you will try to get administrative access, because You do not necessarily need to have that to actually access the data that you want. For example, one service that is used a lot to attack EC2 instances is the SSM. That due to the fact that SSM is, if I could put it harshly, a wrapper around SH, which allows you to send command. So you can execute single commands. You can just have a session, a quasi SH session on the target. You can just run other documents, which will allow you to basically execute code inside those instances, meaning if you have access to this, you can execute code on different instances and actually get other information from them. Another thing is, this is actually something that I do not see many people talk about. When you want to get access to the management console, meaning the web page of the AWS, you need something called a login profile. The login profile is basically just a password that you can use for your user. You can get access to the management console without the login profile. You just need to have a federated token, a pre-signed federated token, which you can put on your browser, and it's going to give you access directly to the web page. And you don't even need the user that has, or any identity that has a login profile for this. You can just use this one. And there are different tools that are doing this. So you have NetSPI Consoler, AWS Consoler, which was the first one that started this, if I'm not wrong. You have Proko, you have Nebula that allow this. So basically, if you have, and another thing is that you will get all the privileges that you usually have on your own identity. So this actually makes enumeration a lot better, because the way AWS works is that when you open the management console, if you cannot access something, it will tell you, you cannot access that. If you use the management console, let's say you have only IAM identity access, IAM access. If you go to IAM, it will list everything. You can do whatever you can. If you go to S3, it will just block that. So you don't need to actually brute force stuff. Basically, AWS will be brute forcing it for you. And since it's basically management console, it's going to be a lot less detectable, because people will be like, oh yeah, probably somebody just logged into the management console with this user. So this is another thing that I don't see a lot of people talk about. Next, we have accessing the S3 overall, so just listing the bucket, downloading objects, uploading objects. You know, one other thing that they do not prevent is putting the encryption configuration on a bucket, meaning you can encrypt the bucket with a key, a private key on the KMS service, which means right now you can ransomware somebody. And this is something that, again, RhinoSec started. We continued as a research. So you literally just put your own key, your attacker key, because KMS keys are cross-account resources. You can have your own attacker's key. You can put it on the target's bucket. You can then just download and upload every object that the bucket has. And you can just lock down the access to the key. Right now, if they don't give you the money or whatever you want to do for extortion, you can just block the access, and that's it. If they give you, you can just allow access to that key, just the key, and they will be able to decrypt the file that they want. So none of them are actually prevented. And aside from that, you are prevented from deleting objects, but you are not prevented from removing the bucket versioning. Bucket versioning is a feature that AWS has, which keeps a version of a file each time it's modified or deleted, sort of wish as a backup, worst case scenario backup, which is bad if you want to ransomware somebody, but it's good if you are able to actually deactivate or disable it before you can actually ransomware them, and then you can do everything that I said, and now they don't have access to the previous versions. Which leads us to the KMS part. Again, they do not filter anything related to KMS, which is strange, because if you are able to use KMS decrypt, you can get data that are encrypted with KMS, meaning if you are able to tamper with a certain key that currently it has files or has any sort of data encrypted on it, you can just get them, and basically the whole encryption thing is, nullified because AWS is the one that manages the keys. And as far as availability, you can always just, worst case scenario, shut down instances, terminate instances, just tamper with their availability, especially if you have cases of one competitor going against another. It's not going to do much, especially if they have a well-defined infrastructure, but it might slow them down. So what is going to help with is doing another form, which is a quasi privilege escalation method, where you use the startup scripts of an instance, so scripts that are executed when the instance is turned on, to achieve code execution on it. To achieve that, you need 3 API calls, one of which is not allowed. But if you can trick the user into actually, or if you can scare them enough into actually turning the instance on, you can just stop the instance, modify the attributes, put your own code in the user data, and when they start it, you get code execution. You can also get some sort of persistence for as much time as you need for them to, just take everything down and continue with forensics. At least you will get enough code execution to at least get the role inside the instance. Lastly, this is the reason why I put this is because this is an impact that we saw with literally this case, the case of leaked credentials. On October, actually a little bit earlier, we found out that those credentials, while we were doing the research, we found out that a group, a whole community of threat actors, were using leaked credentials to have their own AI-based role-play porn site, quite literally, the best way I can put it. So they were all fused by credentials that were leaked on different accounts, and they didn't pay for anything. The targets were paying for everything. They were just testing if they had access to Bedrock. And if I'm not wrong, they had something 70-ish credentials just for that. And they would just, just execute prompts on different models for then they would sell this service to other people who wanted to use this for actually, as I said, role-play porn. This was actually another disclosure that we gave AWS, which is now fixed because of the blog, and we also released a blog. Sorry, it's not showing there, but there should be a blog on the Permiso blog page. And yeah, as I said, this is actually a real impact that we saw of those leaked credentials. Lastly, one thing we saw was that if you remember, I said you get one of the 2 emails. You either get the policy attached or you get the account locked. The reason why you get one of each is because AWS itself does not attach the policy to your user. What they do is they get the credentials that are leaked and try to attach the policy on themselves. Meaning, if your identity doesn't have access to attach user policy or attach role policy, even though to be honest, I don't know if roles will get this policy attached. I've never gotten my role to get this policy attached. If they don't get access to this, the AWS will just lock your account. If they have access to do it, they will just attach the policy on themselves. And another thing we noticed is that when that is done by AWS, both the request parameters, so what you send as request, and the response you get are null for some reasons. Meaning, this is one way that you can detect if a set of leaked credentials has been on your infrastructure. And it's nice that you check this throughout your whole infrastructure history in case you have a set of credentials that you have forgotten to change. All of this led to the creation of Detention Dodger. Detention Dodger is a tool that will basically just run a list user and then will get all the identities that have any of the policies, the quarantine policies on your infrastructure. And then it will tell you if they are allowed or denied to do the certain tasks on your infrastructure, thus giving you the impact that your own leaked credentials will have on your infrastructure. It's also checking for this one too. So even if you don't have an identity with one of the policies, it will still be able to find it. And it will check for all the predefined, or you can even check for the whole IP space. So I even added the check for basically everything in the IP, in the AWS IP space. Now, this was disclosed in June of 2024 to AWS. On August, they released the version 3 of the quarantine policy for you that are part of the cloud security Slack. They even discussed this section. And then on October, we again send them the LLM hijacking part, the impact that they had, and they actually modified the version 3 of the quarantine policy and the version 2 of the quarantine policy. So even if you have identities that are currently leaked and have that policy attached, you will still have the new version of the policy, and they modified these calls. A lot of what we send are not in this. So for example, stuff like Bedrock, stuff like IAM enumeration, and stuff like S3 are in here, and also the STS get federation token, the one that allowed you to get management console access without login profile. A lot of other stuff, especially the privilege escalation that we mentioned, are not in here. So I would recommend you to check the leaked credentials that you have, checked what privileges they have, and checked how they can be impact your own infrastructure, because an attacker, especially if you don't have a locked down account, they can use this. And as I said, we even noticed that being used. This is a list of privileges to look for. These are basically, this is a copy paste of what Detention Dodger is checking for. So you either use Detention Dodger or this one. And just always be reminded that, yeah, any of this can be used to attack your own infrastructure. With that being said, thank you very much. Any questions?